Good afternoon, ladies and gentlemen, Your Excellencies, ambassadors, distinguished guests, colleagues, and our entrepreneurs. My name is Kaspars Stabiks, and I work for the Investments and Development Agency of Latvia. And today I would like to welcome you to our webinar and B2B matchmaking event, Circularity in Construction, Opportunities in the Netherlands and Latvia. Before we begin, I would like to thank the institutions for organizing this event, and I'm pretty glad that together we can foster cooperation between Latvia and Kingdom of the Netherlands. I'm glad for such a high interest rate from Latvian and Dutch companies as well. I think it's straightforward as an indication that we have to take actions for bringing business cooperation between our two countries to the next level. And according to our data, we have about 70 participants today planned in the audience. And now let us begin with our afternoon session. And please welcome Her Excellency Aiga Liepiņa, Ambassador of Latvia to the Kingdom of the Netherlands, with her opening remarks. Please, the floor is yours.
Thank you. Paldies. Good afternoon. Goedendag. Labdien. It is a pleasure for me to join this webinar from the city of The Hague. I'm glad to see also my Dutch colleague, Ambassador of the Netherlands. Goedendag, Howard Jan. I also wish to use this opportunity to thank the Embassy of the Netherlands in Latvia and the Latvian Investment and Development Agency for excellent collaboration on this event. We truly value our partnerships with you that has worked so well for several years on various issues. Latvia and the Netherlands are like-minded countries on several issues, including by being among the strongest supporters of the European Union's ambitious climate goals, the Green Deal, and initiatives with regard to circular economy. Both our countries recognize that future lies in more greener and more sustainable solutions, technologies, which means that circular thinking must extend to all sectors. In other words, in order to fully embrace Europe's circular economy, our construction sectors will need to be even more ambitious in its waste management practices. And there is already some good work ongoing. Having said that, I take it as a very positive sign that despite many hurdles that we all have to face during these challenging times posed by the COVID, construction sector in both of our countries has an interest in transformation of the sector and know how to contribute to circularity agenda, to look for new partnerships and new market opportunities. I am happy that today's business seminar has attracted such a great interest, both from the Latvian and Dutch companies. And I believe that both of our countries, one, namely Latvia, which has one of the lowest population densities in Europe, and another one, the Netherlands, who is densely populated country, have complementary experiences and know-how in the more sustainable housing solutions. Latvia has developed an excellent proficiency in the field of eco-construction and holds a good market position, for instance, in Scandinavian countries. And there is certainly a good basis and interest from Latvian construction companies to expand their businesses also here in the Netherlands. And there are already good examples. Earlier this year, I had the chance to visit one site close to the beach here, where there are sustainable in use and in recycling tiny houses which are made in Latvia by the Latvian company Fabrika Rauna in cooperation with a Dutch company Eco Cabins. And let me say here that quality, design, and overall product made me very proud. And I hope that today's seminar will result in more such good cooperation examples between companies in Latvia and the Netherlands in realizing circular projects in construction. And I also hope that a circular economy will be tested and pushed more and more in every project, so we could in the future to overcome the current production and consumption model, which is based on continuous growth and increasing resource use. So once again, on behalf of Embassy of Latvia in the Netherlands, I thank our partners, but most of all, I thank all the participants for your interest in taking this opportunity today. Have a fruitful afternoon. Thank you. Thank you well. Paldies.
Thank you for these encouraging words. And now please welcome His Excellency Govert Jan Wiel de Vlo, Ambassador of the Kingdom of the Netherlands to Latvia. Please, the floor is yours.
Thank you very much, Ambassador Liepiņa, dear Aiga, and ladies and gentlemen, it is indeed a pleasure to participate in this webinar today from, by the way, what is a fantastically sunny day in Riga. For this online event, our embassy has partnered with the Investment and Development Agency of Latvia and the Embassy of Latvia in the Netherlands. We were also involved in arranging the B2B matchmaking session that is to follow. Now, you may wonder, why does the Netherlands Embassy support a webinar on circularity in construction and the opportunities in the Netherlands and Latvia? This is because one of our policy priorities is to strengthen cooperation between our two countries in deepening the internal market of the EU. And one of the subtopics in this is the circular economy. Given that the demand for raw materials exceeds what our planet is able to supply, shifting towards a circular economy has become a necessity, an economy in which we rethink, reuse, and recycle our world's resources. This is especially true of construction. Waste from construction and demolition apparently results in one of the heaviest and largest waste streams. I understand that within the EU, we generate 461 million tons per year of complex construction and demolition waste. Sadly, the average recycling rate is only around 46%. That is why this sector is so crucial when we talk about the need to speed up the circular transition. The EU Waste Framework Directive requires all EU member states to have a minimum recycling rate of 70% for construction and demolition waste generated by 2020. The Netherlands has a recycling rate of about 90–95%. This is, of course, a positive result. My government has launched a program to become fully circular by 2050, but the shift towards a circular economy is already happening now. Still, much work remains to be done. Together, we can make change happen. Indeed, the Netherlands and Latvia, as the Latvian ambassador already indicated, are among the ambitious European member states that share a common vision to raise the EU target for CO2 emission reduction in 2030 from 40% to at least 55% compared to 1990. And of course, my country actively supports the EU Green Deal. It promises to be a growth strategy which will transform the EU in a climate neutral and circular economy while preserving Europe's competitiveness. Last year, as part of the Dutch Green Deal, 227 Green Deals were concluded with more than 1,300 parties in the Netherlands. Again, this is not to say that things are easy. Only last week, an advisory body on climate advised my government to substantially increase its effort in order to meet the 2030 objective. But the direction is clear. And that is why our embassy in Riga remains committed to supporting the themes of innovation, sustainability, and circularity. The webinar today will have a Dutch touch with Sybren Bosch from the consulting company Copper8, telling us about the latest development in circular construction in the Netherlands, and Jan Kroon from the company Fibercore Europe, who will talk about sustainable solutions in practice, with examples from the Dutch construction market. And I'm of course pleased to note that we have had a good response from Dutch and Latvian companies for the B2B matchmaking session. Finally, I would like to say a special thank you to the Investment and Development Agency of Latvia for their professionalism and support. And let me wish all of you a productive and informative webinar and fruitful B2B meetings between our Latvian and Dutch companies, maybe not face-to-face, but at least screen to screen. Best of luck, stay strong, paldies, thank you.
Thank you, Your Excellency, for these opening remarks. And now let's move on with our first presentation on developments in circular construction in the Netherlands by Mr. Sybren Bosch, Senior Consultant at the company Copper8. The floor is yours.
Thank you for your introduction, and thank you, Mrs. Ambassador and Mr. Ambassador, for, I think, the really strong words in the opening, that the move towards a more climate neutral and circular economy is one in which we're all working together, and one which we should work on together to make sure that we reach our sustainability goals. I've got a short presentation prepared, which I'll now share on the screen. One moment. We did test this. All right, I'll do it differently. Is my screen shared now? Yes? All right. I've got a short presentation around circular construction and the status and recent developments from the Netherlands. And first, shortly about Copper8 and about myself. As introduced, my name is Sybren Bosch. I work for Copper8 and I have a background in sustainable development. So I really look from a perspective of sustainability on how we can change the things we're doing in such a way that we can do them in a future-proof way. Copper8 is a small consultancy based in Amsterdam and focused on sustainability through collaboration. And Copper8, the name Copper8 comes from cooperate in English, because we think cooperation is often the missing link in working towards higher sustainability performance. We basically do three things. We focus on consultancy, focusing on impact and how we can achieve sustainability impact there. We are a think tank and we try and develop knowledge on critical issues that we need for this transition. And third, we are also participating in the circular economy, and we're co-developing the Access Materials Exchange, which is an online platform, basically a dating site for secondary materials, to see how we can exchange these secondary materials to a second life to reduce primary material use. To start with, I think most of us know, but at least what drives me and which would make sure I get out of bed every morning is our huge sustainability challenge. Because the next 10 years, if you look to the graph from the IPCC, the International Panel on Climate Change, to stay below 1.5 or below 2 degrees, we need to significantly reduce our carbon emissions in the next 10 years. So that's a relatively short term. And to reduce our global emissions by approximately 50% in the next 10 years requires enormous efforts, not only of public sector, but also of the private sector, because everyone is responsible and everyone can take action based on what they're good at doing. And why is the circular economy so important? Because mainly in climate discussions, we're focusing on the energy used for transport and used for electricity generation, but not on energy used for products and construction. And the energy used for products and construction is actually 45% of our global climate impact. And therefore, circular economy can have a huge contribution to the climate goals, which we're all trying to work towards. If we look to the construction sector specifically, and this is a visual from the Ellen MacArthur Foundation, we see that toward 2050, we're expecting an increase in carbon emissions from the construction sector because there needs to be an increase in the amount of buildings that needs to be constructed globally. But circular economy perspectives and principles can actually reduce that carbon impact by about 40%. And this is, I think, why it's so valuable to look to these circular economy principles in construction. How we from corporate look to circular economy, often we see that it's being a technical discussion. So people are talking about different design principles and different materials, but actually to move towards a circular economy, we need to go beyond this technical approach. We also need a different process of cooperation together to really see how we can cooperate based on trust, based on long-term perspectives, make different types of agreements with each other on how we cooperate and how we use each other's expertise. And we need different financial models to provide incentives actually that support higher quality products, that support longer lifetimes, and that support product performance over product sales, which we often see happening also in the construction sector. How we approach circular construction, and the visual you see here is actually quite an old one from 1994 from Stuart Brand. Some of you might know it, some of you don't, therefore I shortly explain it. It is a concept of building layers, so-called S layers. And we think it's a very useful model for circular construction because it actually shows the different layers that you have in a building. And these different layers have different functions, but also different lifetimes. So going from long to short lifetimes, we have the site, of course, like the ground on which your building is standing, the structure, the skin, the services, installations, energy mainly, the space plan, which is the interior walls and those kind of elements, and the stuff, which is the furniture, the chairs, everything. And what the basic design principles are that follow from Stuart Brand are designed for disassembly between layers and designed for adaptivity based on future functions. So you should be able to take every layer apart from the other layer without damaging the other layer, and therefore it's always possible to reuse building components if they are built and designed for a long lifetime. How do we then make that practical towards construction? Basically, if we look to circular construction, we divide it in two elements: circular material use and circular design. Circular material use is, of course, about reusing materials and components, about using bio-based materials, which also reduce our need for new technical materials with intense and climate impactful production cycles. And therefore, after using materials with a low environmental footprint, if the other two options are not possible. And if we look to circular design, it's about designing future-proof, so based on adaptivity, that you can change buildings or interiors. Design for optimal use, based on its functionality, so that you can actually use products based on what you need. And design for future life cycles, so design for disassembly, making sure you can take everything apart, that connections are dry, etc., etc. Where is that applied? I've got two sheets of examples, one of buildings, one of infrastructure. If we look to buildings, the left picture is a project in Amsterdam. It's a housing project where over 95% of the materials were reused on site. In the new construction, you don't see it, but almost all the materials are reused from the demolition project of the previous housing, which was here. Second example, which is the greenhouse. It's a temporary restaurant in the city of Utrecht, and it has many product as a service components. So that's what PaaS is standing for, product as a service. And basically many things from the exterior to even the plants which are in there, to the furniture, to many of the installations, they're all product as a service bought. So basically they're not bought to provide ownership, but bought as a service, and the components remain owned by the company who supplied them. The third example on the right is the temporary Amsterdam courthouse, which is also a temporary building, where there was need for because the old courthouse would be demolished and newly built. And the interesting thing there is that it was offered by some market parties with a 10% residual value at the end of the 5-year lifetime. Moving on to infrastructure, on the left side you see a bridge. It's actually the old bridge. We're presently constructing a new one. We're really focusing on industrial, flexible, and disassembled design, meaning that we have standard sizes of components and standard connections between components to make sure that we can build many bridges from an industrial perspective, and therefore do that quicker, do that with lower environmental impact, and do it with lower impact for all the users of the bridge, both cars and bicycles. In the middle, you see a light as a service project in the south of the country, in the province of North Brabant, where Dura Vermeer, which is a large contractor, actually designed the light as a service contract with the province to really see how they could be responsible for the lighting and for the lights shining in a certain performance, and get money for that performance instead of letting the lights burn all the time. It already led in the first half year to a 30 to 40% energy saving, and in a 15-year business case, it would lead to, I think, 60% lower costs for the province. Don't pin me on the figure, but it's significant compared to the previous situation. Third, on the right-hand side, you see a bridge in the north of the country, in the city of Ritsumasil, and that's a bicycle bridge completely made of innovative bio-based materials, which is now an iconic project for the country to really see how we can move to materials with a lower environmental footprint. Closing off, some relevant developments from the country if we take a national perspective, which might be interesting for Latvia as well to see what's happening in the Netherlands and how that is moving from a structural perspective. First is that we have quite a strong national policy on circular economy, with actually two sort of visionary aims, being 100% circular in 2050, although no one really knows what that means. Therefore, it's a visionary aim which we're really trying to move towards without knowing exactly what the end result will look like. And we have a bit stronger aim for 50% raw material reduction in 2030 compared to a baseline year in 2014. Really trying to see if we can cut our raw material use strongly. That is at present being worked out, and it's actually quite difficult because we need, amongst others, an increase in housing production, but really trying to see how we can reduce the raw material reduction from a wider perspective. Second, we're having a national strategy for circular construction, which was co-developed between the government and the sector. That's the typical Dutch approach, it's co-development, but it really works well, at least in our opinion. Third is that increasingly we have a focus on circular procurement by public bodies, and therefore also trying to ask circular solutions through procurement, also in the construction sector, but also in other sectors. And fourth is that we're having a national platform called CB23, that's Dutch for circular construction in 2023, where we're trying to create universal standards for circular construction. In 2023, they should be there, therefore the name. And we're already having published 2 guidelines, one on material passports and one on how to measure circularity. Closing off with a quote by Winston Churchill, which I always like, if we look to construction, is that we shape our buildings, but thereafter they shape us. Therefore, the impact we have from the construction sector on how people use the buildings and how people perceive being in a building is definitely something we can influence, and that also applies to the climate and material impact of our construction sector. Thank you so much.
Thank you, Mr. Bosch, for this complex and interesting information. And before we move on, I just wanted to tell our audience that there is a possibility to place their questions in regard to our material, to our today's subject, in the Q&A section down below. So we are going to try to answer you whether directly or we have a small Q&A session at the end of our webinar. So once again, Mr. Bosch, thank you very much.
You're welcome.
And our next topic is sustainable solutions in practice, examples from the Dutch construction market. And therefore, please welcome General Manager of Fibercore Europe, Mr. Jan Kroon.
Yep, thank you. I'm going to share my screen. I hope you all can see it. So, thanks both Mrs. and Mr. Ambassador from both the countries. A very warm welcome from Holland, from Rotterdam. We are very pleased that we are able to give the presentation. So thanks to the organization for inviting me as well. My name is Jan Kroon. I try to see the next slide. Yeah, my name is Jan Kroon from Fibercore Europe. As I mentioned, I'm together in this webinar with my colleague Marta Chevalier, with who some of you will meet later in the matchmaking event. She is also in the webinar. I want to introduce very shortly our company and then go to circularity in bridge construction. We are producing FRP bridges and log gates for more than 14 years. And our first bridge was already built in the last century, 1997. And now in 2020, we are 1,000 bridges further, let's say, in history. We manufactured over 1,000 bridges, and they found their way throughout the Netherlands, Europe, and even worldwide in China, Australia, and United States of America. FRP, fiber reinforced polymers, let's say glass fibers and resin, is nowadays accepted as a construction material besides the traditional materials, concrete and steel, and sometimes timber. And we have ambitions to expand with this material with partners worldwide, with agents or licensed partners. And I think it's good to mention that we have unique infracore inside technology. It's a very robust technology which enables us to manufacture constructions with a very long lifespan. So in our opinion, we are producing sustainable and circular bridges in very many ways, and I will explain that to you in the next 10 or 15 minutes. As said, we are a very international company with partners and agents already in many countries all around the world. We hope to sign a license agreement with an Australian partner within 2 or 3 weeks from now. We have licensed partners already in Canada and the United States of America. We delivered projects in many countries, and we have a very strong focus on the Baltics and the Nordics, because we think that sustainability and circularity is at a very high level there, and there are possibilities, as mentioned already by both ambassadors, because the countries and the character of the countries are more or less the same, and we can become very good partners in this as well, is what we believe. This is what we are doing, bridges. We are producing bridges. On the top left side, a bicycle or pedestrian bridge, not that big. On the top right side, you see a very large bridge deck still on transport to its final location for a traffic bridge. On the left side, on the bottom side, a beautiful bridge in Amsterdam, all made of one part and then installed, including the handrails in one time. And the picture on the right side, on the bottom right side, some of my colleagues last year said, this is the most ugly bridge we have ever made. And some guys said, well, it's the most beautiful bridge we have ever made. But it's a bridge for animals. It's what we call an ecoduct. So rabbits and deer and rats can cross the water. And it proves to me that we are living in a very rich country, let me say that. And, but from a constructive point of view, it was a very interesting project for us as well. Talking about circularity, and I'm glad it was mentioned by the former speaker as well. I'm thinking about the Ellen MacArthur Foundation model to use when it's about circularity. The use of the product of the construction should be as long as possible, with a minimum of maintenance also if possible. And after that, when it's come to the end of its function, try to reuse the construction or the material in another way? And after that, is it a possibility for refurbishing? So with little adaptations to the construction, maybe you can use it on another way as well. And then after that, recycle it to its original components. And for FRP, it is now that by techniques like pyrolysis, we can already bring back the FRP structure to its original materials, glass and resin. And if you bring in bio-based materials, and there is, as you have seen in the presentation before, there is already a first example in the Netherlands from a bio-based bridge. If you use more and more bio-based materials in this, the circularity even will be better. And later on, I will show that our products are touching the goals of the circularity model of the Ellen MacArthur Foundation quite a lot. It's also about sustainability. We know that the United Nations had formulated their sustainability goals, but also where the ambassador of Latvijā in the city of The Hague, they have formulated goals when it is about sustainability. A construction should be a future landmark, it should have value, should be realized in a very social way, and of course with a minimum of raw materials, a minimum use of energy. It should fit in a natural way in the landscape. That's all has to do with sustainability. And let me show some examples now that proves that we are manufacturing sustainable and above circular products. We install bridges like this within 1 hour. So when it's about sustainability and avoiding noise and disturbance in the city, we come with one truck with one bridge, which is fully complete, and install it within 1 hour. It also means it can be deinstalled afterwards, after 2 years or 20 years. That's no problem at all. And I have some other examples for that as well. We bring them one complete bridge on one truck. So it doesn't take that much time. It doesn't take that much effort. We can bring a complete bridge to its final destination in one time. And especially in bigger cities, this is really an issue, avoiding disturbance in the cities. This is a beautiful bridge. This one was still in our factory, and we tested the light in the railing. But what does it have to do with sustainability and above all circularity? Here you see the bridge in the city of Malmö in Sweden, and we installed it there also in a very easy way. But we could use, or let me say reuse, the historic cables as abutments for this bridge. And that is possible because of the very lightweight of the FRP materials. You should imagine that a bridge like this is about 4 tons in weight. So it's very easy to install, but there are hardly no extra loads on the existing cable as well. So this was a big advantage and therefore a reason to choose for this material by the city of Malmö. This is another example. This is in Belgium. It's an existing railway bridge, but they have to give it an extra function because they had to build an extra bridge for a bicycle path. But they were able to install it to the existing bridge with supports, and that also was possible because of the lightweight of our panels. And these panels, with a width of about 2.5 meters and a length of 20 meters, can be reused if the function in this location should come to an end. You can deinstall them with the connections and use the same panels on another location if needed. Another example, this one is in the southern part of the Netherlands, in Kerkrade. Quite an historic bridge, a monument, but the monument couldn't function as a bridge because the deck was in very bad condition. But they wanted to keep the monument, and they wanted to keep the let's say, the eye catcher of this monumental bridge. It's going to be repainted and made corrosion free, and the deck, the timber deck, will be replaced by a FRP deck, and that is so much lighter that the lifespan of the existing bridge can be enlarged with at least 30 years. So they didn't have to build a new bridge. They can use the old monumental bridge, and then it can last for at least another 30 years with the new loads, with the new engineering, according to Eurocodes that we have to use now when building bridges. And this is another, let's say, very simple bridge. And you may ask, well, why are you showing this? But this bridge was already used on another location before, and it was there 4 or 5 years in a function as a bicycle bridge. But then they decided that they needed a bridge somewhere else, and they picked up that bridge. They picked up the bridge, they de-installed it, and installed it on the new location. I can tell you that we produced already 10 bridges, and we have some in stock, and some are delivered on locations for, let's say, half a year or 2 years, and then we take them back and bring them to another location. And there is also an initiative in the Netherlands that is called the Bruggenbank, where you can put on, it's a website where you can put on your bridge, and there might be a bridge that you can use in your situation. And with FRP, it is very easy to do so because of the lightweight of the bridge, and you can pick it up in one piece and bring it to another new location. And therefore, it keeps its function as a bridge, although that the bridge on the first location isn't there anymore. We are also participating in a European project that is called Smart Circular Bridges. Let's say that it comes to a following next project in the Netherlands with a bridge of bio-based materials. I expect the bridge to be built in spring 2021, and in 2022, 2 more bridges in the Netherlands and also in the city of Ilsfeld in Germany will be built with our materials, with bio-based materials. So, talking about FRP as a construction material, I think it's a green building material. We also use already resin on the base of PET resin, so a PET material out of recycled bottles. We can replace them and reuse them in another location. As said, 100% prefabricated bridge. When we make a bridge, it is fully complete when it goes to the building site. So when you come into a big or a busy city, it's a one-time transport and install the bridge. As said, we can bring back already the FRP to its original components, and I also do believe that bio-based bridges will be a bigger part of our FRP production line in general. So in my opinion, FRP is a very green building material. And back to the sustainable goals, we touch quite a lot of goals that from the United Nations of the City of The Hague, when it is about sustainability. When it's about circularity, the lifespan of our bridges, they can be used over 100 years. They need quite a minimum of maintenance, but if maintained very well, they can last for over 100 years in one situation. You can reuse them with small adaptations. You can refurbish them or remanufacture them for a new situation. And afterwards, you can even recycle them to the original components. So in our opinion, FRP is a very circular building material in infrastructure. And that brings me to the end of my presentation with a final question for you. Which bridge are you thinking of now? You might not have the answer right at this time. I give you one example, and I realize very well it's not in Latvia, but it's in Estonia, and we are very proud to produce, right at this moment, to produce the bridge decks for this beautiful bridge that is going to be realized in the city of Tallinn. We are actually this week producing the bridge deck for that. They will be transported after 2 weeks from now, and then somewhere spring next year, the project should be finished. And we are very proud to have a, let's say, a future landmark in the Baltic area, and we hope many bridges more to come. Thanks for your attention on behalf of my colleague Marta Chevalier, as well. Thanks for your attention, and we'd like to meet you in the B2B matchmaking event afterwards. Thank you again.
Thank you, Mr. Kroon, for this lovely presentation. And before we move back to Latvia with our next lecturer, Kristaps Draudiņš, we have a question from the audience. And I believe maybe you can answer it. The question is from Jānis: what is the expected life of a fiberglass bridge?
100 years at least. That's and of course we engineer it on a certain load, and if that loads are still going to be used after 100 years, then the material we can guarantee that for a lifetime for over 100 years, with no maintenance at all. So we have no degeneration because of UV light or salt that is used on the roads. So it's a very robust material with a lifespan over 100 years.
Thank you, Mr. Kroon. So, and next we have a case study on our agenda, sustainability aspects in communication with clients. And please welcome Mr. Kristaps Draudiņš, Director of Control Factory. Kristaps, the floor is yours.
Thank you very much for the introduction. I hope you can hear me well. And so my name is Kristaps Draudiņš, and I will share my screen. I will show you a short presentation of ours. Can you see it? Is it on? Perfect. So I am a CEO of a company Control Factory. So we are a Latvian company, and we are relatively new in the market. So we are active since 2016 at the moment. And we are working in different countries, in all Baltic states. We are working in Sweden, we are working in Norway, now in Finland. And of course, we would like to also start to do some activities into the Netherlands, which is in our mind very interesting market for this kind of product. So what we are doing and why this is related to the circularity in construction and sustainability is we are producing a material, which is a raw material. So it's a woven glass fiber treated with some specific compounds so that it's completely fire resistant. And from one side, it's coated with the stainless steel coating in a very thin nano layer. And in the end, we are producing a very highly electrically conductive and sustainable material. The reason why we are doing something like this is because mostly we are working into the flat roofing market, so into the construction market. And from our previous experience, we understand that flat roofs might be challenging very often. And I mean that there might be some kind of problems in the flat roof, which can lead to a leakage. And very often these problems arise not because of the material quality which is used in the project, but most often they arise because of the human factor. And if something like this is left behind in your roof, in your terrace, or in your balcony or similar facility, then it will become a leakage after some while, and then there will be a lot of problems which will give you a lot of headache and a lot of financial losses, and unnecessary and premature renovations. So our idea was to develop something which can detect these damages before the wet water gets inside the roof. So we have developed a proactive solution, and eventually it prolongs the life cycle of the roof and of the whole structure itself, which means that it reduces the construction waste. So how it works? Our material is installed under the waterproofing in the whole area of the flat roof. And with these kind of specific equipment, which you can see in the image, you can find all the smallest damages or holes in completely dry conditions. So before there is a water leakage. And this system works with most of the materials which are used on a flat roofing market. So this is a very small principle which shows you the functionality. So our material is always placed right underneath the waterproofing membrane. And during this inspection, our material is electrical minus, and this inspection equipment, or to put it simply, the brush, which you take on the roof, is electrical plus. And if there is a hole or a cut or some kind of a damage, then it will give you a visual and audio signal, and you will be able to pinpoint exact locations of these damages, which can be repaired after that. The inspection is usually carried out by the roofers at the moment. Of course, we can offer this as a service as well, and we have some partners in different countries who are doing this as a daily job. But more often, the roofer who is taking care of your roof and who is installing all other materials, they can do this inspection. So we offer to train them, and we offer to provide this inspection equipment as well. And sometimes it's even becoming more popular that the real estate developer or the client of the building is willing to purchase this equipment and take care of their own roofs by themselves. So these are only some examples from real life how the material looks when it's under installation process. So this black one, this is our material, and it goes right under the waterproofing layer. So these are different kinds of waterproofing membranes and different kinds of cases. So our material mostly, as I told you, is used on different kinds of flat roofs, but also terraces, and more often underground parkings, which is basically also a flat roof. Then we are trying to cooperate with the biggest players in the roofing market, meaning that at first we are very interested to receive their approval that our product is good to go together with their systems, with their materials. And the second step is that together with them, we are trying to introduce our product into different markets, to different clients and to different industries even. Then very shortly about how different our projects look like, because they are not always very typical big flat roofs. So they might be, like in this case, it's a skiing village in northern part of Sweden. So it's not even a typical flat roof. It's a roof with two slopes, but still they use the PVC membrane. And the company who built these buildings, they were the ones who inspected them before they give them to the client, so that nothing is left behind. Then we have different kinds of private houses. This one is a nice reference project also in Sweden. But most often our projects looks like this. So for example, this one is a residential building. This is a office building. Then we have a lot of municipal projects, like for example, this is a school, but we also have some kindergartens. We now have some airports, now hospitals. Then we have commercial facilities. So this is a very big supermarket in the city of Riga. Then we have big green roofs, which is becoming more and more popular to put something on top of the membrane. And in these cases, if you leave something behind, then it might be a very big problem. The leakage might be a very big problem. Then we have hotels. We have different kinds of production plants. In this case, the client was very satisfied with our solution, because For them, underneath the roof, they also have a very expensive production equipment. And it wouldn't be only a problem if the roof would leak and you would need to find where is the origin of the leakage and to repair and to spend some time and money for this, but also there's a risk of something happening with the equipment underneath the roof. So in this case, and how it's how it's usually happens on the roof, the roofer finishes his part, and then the roof is open to other companies for quite some while. It might be months. And this is the biggest risk when something might happen. And most of these damages happen already during the construction phase of the building, meaning that the roof is already damaged in the new building. And only after some while, these leakages appear. And therefore, there might be some premature renovations, which could be avoided. And then we have some underground parking projects like this one. Again, it has 60 centimeters on greenery on top, and the main contractor who installed this, who made this project, they were very smart, and they inspected each part before they installed this green roof very carefully. They found some holes, so these holes were repaired, and now the roof is watertight. And this is one of the latest projects, but this is a very nice one. It's the biggest data center in Baltic states. And naturally, of course, for them, this is also important that the roof is completely watertight and there wouldn't be any problems. And you can imagine that under the roof, there are a lot of servers and other things which cannot get wet. So this was very shortly about us and what we are doing. So thank you very much. And
thank you, Kristaps, for this insight. And yes, looks like our today's webinar is almost came to an end, and we would like to remind you that if you later on have some questions to some of our lectures, you can feel free to write them an email, and you can access the email, the exact place where you applied for this webinar. And hopefully the next time we have this sort of event, and this is going to be live in person and not through a computer screen as we are used to work in these conditions at this point. So the last question goes to Jan from FiberCore, and then we continue with our mutual B2B matchmaking events. Jan, do you use wood in your bridges? If you can, maybe you can name some examples. This is from Jacques.
I read the question. No, in our standard bridges, we don't use wood as a core material. So it's only FRP in the webs and in the top and bottom flanges of the construction, and there's a foam core inside it. And we are cooperating also with our partner in Australia to use more recycled components in this foam material. But there's no wood in it. We once produced one time a bridge with balsa wood that can be a very, let's say, sustainable solution as well. But on the other hand, some of the advantage will disappear because of the weight of the bridge will become bigger as it was, let's say, in the standard situation. So, but the core material is definitely a material that we want to improve further in terms of sustainability.
Okay. Thank you, Jan, for your answer. And as I said previously, that if we are going to have any answers, then maybe we can come back to you in email version.
Yeah, well, I see one more question. What is the smallest bridge?
Yes, exactly. It just came in. Maybe we still have a minute, so maybe you can answer that.
Normally we get questions in just as what is the biggest bridge you have ever made, but the smallest one, well, I don't know exactly, but it's about 1 meter wide and a span of 5 meters or something like that, just at the entrance of a house or something like that. That can be the smallest. We can make very small panels that can be used as a bridge. And well, the biggest bridge in one element transported by truck was 4.5 meters wide and 42 meters length in one panel, and it was transported from Rotterdam by truck during the night to the city of Brugge in Belgium. And
okay, thank you, ladies and gentlemen. Your Excellencies, ambassadors, thank you for taking the time to inform us today about these fruitful endeavors, and I wish you all the best, and I wish you a fruitful B2B session. Thank you.
okay, thank you.